everyone, my name is Tushar, and today I am going to demonstrate Mimir, which is the solution we have created for this particular hackathon. So, if you have used an AI coding agent for more than a day, you have probably noticed something a little frustrating. They are really smart, but they don't remember anything. It will work out some tricky bug for you today, and then tomorrow, brand new session, it walks straight into the exact same mistake. Whatever it figured out just disappear. And most of the memory tools people are building for agents right now, they basically just save a pile of text and hope some of it turn out to be a useful later. So to solve this specific problem, we built Mimir, and the idea behind it is pretty simple. Memory. So to solve this particular problem, we built Mimir. And the idea behind it is pretty simple. Memory that actually has to prove is helping or it doesn't get to stick around. The way it works is fairly intuitive. When the agent fails at something, Mirman notices and writes down what actually happened. Then it takes the failure and boils it down into a one clear lesson. And it signs it so you always know where that lesson came from. Later on, when the agent runs into a similar situation, Mimir can handle that lesson back to it. But only if the lesson has built up enough confidence to be trusted. If it's a bad lesson, it doesn't make it through. Every lesson has to earn its spot. Okay, so the real question is whether any of this actually makes the agent better. That's the part we cared about most, so we went and measured it. Same model the whole way through. So we used the same model whole way through, that is Claude Sonnet 5. Same three tasks every single time. The only thing we ever change is the memory. With no memory at all, the agent gets zero. It fails all three because these are the bugs where the uh, fix depends on some specific API behaves. And there's just no way it could know that from training. Now we switch Mimir on it's on 100%, all three. And I actually want to be honest about this middle row because it's the interesting one. This is memory with gate turned off, and we deliberately fed it a wrong poison lesson to see what would happen. Most of the time, Son is smart enough to look at bad advice and just ignore it. But on this one T unit, it fails it completely. 0 out of 3. The only reason the real version gets it right is that Mimir Gate caught the bad lesson before it's ever reached the model. And none of this uh, is a slide I dressed up. Let me just run one uh, live command through the terminal. So this is the test we created for evaluating Mimir. So I will choose the Sonnet 5 model and then this is the script we have written. So here is a broken code that Mimir pulls up for it. And this down here is the fix the model actually writes back. And the score at the bottom isn't us matching keywords or anything like that. We literally run the code against the hidden test. If it comes back as 1, the bug is genuinely fixed and we run the whole thing 3 times. So one lucky result can't sneak into it and a real and look like a real win. So that's really the whole idea behind Mimir. Memory you can't tie back to an actual result, it's just storage. We wanted the memory that earn its place, and right here is a proof. Using Mimir, you can actually improve your day-to-day daily coding tasks as it keeps on learning using real lessons. It has episodic memory as well as the lessons created by Mimir itself. Thanks for watching.